Well, Paul is here and there's a eager audience here, so we don't need to wait any longer. Most of you will know Paul Hart. I was talking to somebody yesterday who'd never been into radios or tubes or any of that stuff. And they'd heard about this, they came to look at it. And I said, well, we have this guy who knows a lot about tubes. And a couple of years ago, he decoded the manufacturer's codes that were used for Sylvania. And for several years, nobody knew what the codes meant, but he figured it out. And they said, wow, he must have done a lot of interesting research to figure that out. He knows a lot about tubes. He knows a lot about tube testers. He's one of the very, maybe handful at most, of people who can restore a tube tester. And he's one who will be honest with you about whether it's worth restoring as well. And with no further ado, I turn it over to Paul.
Thank you, John. Oh, stop it. Thank you. We had trouble deciding what to call this presentation. It ended up on the chart as the introduction of the Lochtel and the miniature vacuum tubes in just before World War II. And we came down to this, and we had a number of iterations as to how to pitch this. This presentation is not going to talk about any of this stuff. It's all about receiving tubes. And there is so much to talk about that somebody's going to be irritated by the fact that I didn't talk about what they thought was most important. So you're going to have to, I have to ask for your indulgence in that regard. And let's go on to the next slide. Okay. The organization of this discussion is, we're going to talk to what my view is of the early transition to what I call the modern era. The joint activity between two manufacturers and circuit designers, which was very intense in the early 1930s and resulted in the superheterodyne that we understand today, what the industry position was after World War II. And then we're going to go into the developments to meet new demands, television, radio collection, restoration, and then moving into the modern era, the audio craze, high fidelity, and the guitar guys. And there's Randy, and recent developments that you may not be aware of. Let's go to the next slide. This is a sheet from a paper that was put together by brother Patrick Dowd at the American Wireless Association in September of '78. And what it does is it shows the years in which tubes were released by RCA. And in those releases, you can see the evolution of the development of vacuum tubes and the circuitry. I call the modern era that it started in 1927 with introduction of the 27 and the 80. RCA held the superheterodyne patents and refused to license it to other manufacturers. And if you will recall, about 2 years ago, I did a presentation on the way RCA misused and manipulated that dominance to hold everybody else to a disadvantage. And in 1930, of course, the federal government was part of the formation of RCA. The federal government got so mad at them that they brought an antitrust suit and forced them to license the superheterodyne patents. And from there, the industry exploded to build more and better superheterodyne receivers. 1931 was the beginning of development of superhet tubes to establish the modern circuit. 32 was the beginning of massive releases, and by 1935, the basic modern receiver design had been established. And if you look at these releases, you can see the whole thing coming to pass. In 26, the 71 came out. In 27, it became the 71A with the more modern filament. So here's the 27, here's the 80, 81. In 1928, you got the 50. You got in 29, you got the 45. In 1930, you started to get tubes that could manage AVC. So now you had the development of effective automatic volume control. You know, in the early days, anybody who wanted to listen to a radio at night had to have some kid working the volume control all the time because the signal level was going up and down. And Ed Lyon, in his discussion tomorrow, is going to tell you probably more about AVC than you wanted to know, but it's going to be very instructive, and I refer you to that discussion. So by the time you get to 31, you've got these control tubes. Now here you start to see the tubes that you recognize as relatively modern, the 56, 57, 58, all 2.5 volts. And then in 33, you start to get the 6-volt versions of these tubes. And now you're really recognizing the tubes, and a 75 became a 6C6 and 78 became a 6D6 after they started registering tube releases with the Radio Manufacturers Association. Go ahead to the next slide. Okay. One of the biggest advances, in my view, was the development of effective AVC, because that with the development of effective superheterodynes really made radio practical. And what they originally called it was super control, a variable mu pentode. And the way what happened was, if you had tubes that were all sharp cutoff, as soon as you start putting bias on them, they just cut off. And so the action of that whole thing, if you could detect and get a negative bias voltage that was proportional to the strength of the signal that you're receiving, the receiver would shut down very rapidly, and it was very crude. The way they controlled it, if you look at this, you can see that what they did was, instead of winding the grid continuously, uniformly, they opened it up part of the way through and then tightened it up. So what you have over here on the far side is an ordinary pentode to 6SJ7. See how fast it cuts off. At 6 volts, there's no plate current at all. On the variable mu pentode, you have to really beat the crap out of it in order to get it to shut down. And that's what gave you an effective AGC control curve. And once you had the diode detectors instead of the old grid leak detectors, and you had the tubes that had the control grids that would handle that, when you put all that together, now you've got the modern, what I call the modern superheterodyne receiver. Because if you look at a service manual, all in 1935 and on, you got all basically the same circuit. Everybody's got variations, but it's basically the same. Go ahead, next slide. Now this, Ludwell Sibley did tube lore, and prior to 1934, manufacturers assigned their own designations to tubes, and you know what kind of a mess that was. You're still dealing with it when you're dealing with old tubes. There was only voluntary industry uniformity in numbering, but in 1934, the tube manufacturers got together and decided this was ridiculous. They formed the RMA, and now they assign designations to be the repository for listed tube characteristics and the numbers. And many tube manufacturers continued within specific designations, many of which were widely accepted. You know, RCA's got the 807 to 16 series, all. Then there's a whole series of just 4-digit number things that were registered, but had specific uses. Go ahead, next one. Acorn tubes. These surfaced in the 30s, primarily for military application. And they were introduced in 1939. And these were the first ones that were released. And that is an Acorn tube. Okay, the all metal tubes were announced in 1935. And these tubes, which you will recognize the numbers of, were part of it. And the funny thing is that the 6Q7 is not on there, but it followed very shortly because that's the tube that had the diodes. And for some reason, they didn't do it right away. And that's why you see so many radios with 6F5s and 6H6s in them instead of a 6Q7. Of course, if you were Zenith, you were counting tubes, so the more the better. So anyway, go ahead, next slide. The beam power tube. This was developed in Europe initially, thought to be too expensive to manufacture by Marconi Osram. They invented the beam power tube, and Rossetti made a presentation that's on the website, Past Events Monthly Presentations, and here's a link to it. I acknowledge it because it's so important and it had a major effect on the whole business of power amplifiers. They shared this with RCA, and the reason they thought it was going to be too expensive is it required the development of aligned grids, and they thought it was going to be too difficult to manufacture. But it didn't take them long to change their mind. GEC released the KT66 in 1937. And whether it's apparent or not, even the 6L6 GC in 1959 did not match the performance of the KT66. The 6L6 GC had 30 watts of dissipation plate, and the KT66 only had 25. But the GM was higher, and the tube was released in 1937 in Europe. Now by 1936, you've got the beam power tube invented, and the effect of that goes all the way up to the end of tube manufacturing. And to this day, the tubes that are made, many of them are beam power tubes. Go ahead. And here's the diagram where you align these grids so that the screen grid is aligned directly with the control grid. So you have a very low screen current and you have a sheet of electrons. You see the shape of the cathode, it's not round anymore. And that's what this is all about. And again, I refer you to Rossetti's previous demonstration and presentation for a lot of extra detail on that. Go ahead, next. Sibley makes a big deal out of the fact that Lockdoll was a Sylvania term that couldn't be used, it was licensed and couldn't be used by anybody else. This is a Sylvania technical paper from 1942. They call it lock-in. I don't know where Ludd got that, but it's been widely accepted. Anyway, in 1938, Sylvania introduced the first lock-in tube, the 1231, later the 7B7. And it was very interesting because for the first time they had other than the acorn tube, they had a direct seal from the leads coming down from the tube all the way to the pins. That had a lot of advantages because it was lower capacitance, lower inductance. It allowed the tubes to go to a higher frequency. And it also assisted in dissipating some of the heat from the tube down through the pins into the socket itself, which actually allowed them to have a higher dissipation rating than they did in the old style of pinch design, the way they built them. Registration of new Lockdoll or lock-in tubes ended in 1947, but as you guys well know, you're still looking at buckets of tubes, Lockdoll tubes used in radios, and in a lot of military equipment, car radios of the 40s and 50s, they were very popular and very widely used. Some tubes, like the 7F8, took advantage of lower capacitance and inductance to reach higher frequencies than you could with a regular twin triode of the day. Go ahead, next one. Okay, then this started now we're to the original title. Now we got the lock-in tubes. And in November 1939, RCA introduced the first miniature tube types. They were the 1R5, 1S4, 1S5, and 1T4. By the war's end, there were 34 miniature tubes that had been released and were in use both in military and other equipment. There was the Lighthouse tryout in 1940 for microwave communication sub-miniature tubes. The Novar 9-pin, the 1287 was the first one of those that was released. The button stem octal in 1950. The new Vista in 1959 by RCA, new types to 1967. And the Compactron in 1961. And the Novar. RCA wasn't happy with the Compactron, so they had to have their own. So they went and did a 9-pin. Novar late 1961 and 78, 68 was the first. And a lot of you audio guys know that as a 7591 with a 9-pin base on it. Go ahead, next one. There was a tremendous amount of technological development driven by World War II. World War II was the first technological war, and in a previous discussion, I talked about radar and the adoption of the cavity magnetron in the United States that completely broke through the design problem of building effective long-range radar equipment. And of course, the radar equipment, the fact that they could now have the power and the ability to receive a return signal created the need for all the other equipment that would support that. And radar was one of the best kept secrets of World War II. It was fantastic in the ability of the United States and the Allies from starting from a defensive position to be able to manage the offenses of the original attacks in World War II. And so there was a tremendous amount of development that was triggered by the need to support the development of all this radar equipment. Development of the VT fuse. I did a presentation on that, which allowed you to fire a 5-inch shell and have it detect being close to an airplane and then pop a 5-inch detonator warhead within 70 feet of an airplane. That usually took it down. And that's what broke the buzz bomb attack on England and it also broke clear the Anzio beachhead in Italy. And all this was, they didn't want anybody to know about it. They didn't want the foreign people to realize that we had been able to do this. And ironically, Sylvania developed the first effective tube. The deal was you had to have a vacuum tube that would stand being subjected to a 20,000 G shock coming out of the barrel of a 5-inch gun. And Merle tube and the joint Applied Physics Laboratory of Johns Hopkins in Sylvania in Salem, Massachusetts is where that all got worked out. Everybody knew that it was possible to do this technically, but nobody could build a tube. And these guys figured out how to do it, and they were building 50,000 of these things a month. Anyway, now there was also the demand for electronics by domestic industry for wartime expansion. If you build a new factory to build airplanes, you got to have communications, you got to have all kinds of other stuff. And you don't think that much about it, but this required tremendous amount of additional production on the part of the electronics industry in the United States. Go ahead, the next one. This is an example of some of the stuff that happened in World War II. Western Electric developed the 6AK5 specifically as an IF amplifier for radar sets. The one on the right is notable in that it weighed only 9 ounces, had a 100 dB gain with a 2 megahertz bandwidth, was completely stable with no adjustments. Of particular importance was a low noise 6AK5 using the smallest amplifier. This had the 717 doorknobs. You've seen a lot of those. And this was all 6AC7s. They all had to be carefully aligned and fiddled with to get to work. This, you plugged it in. And that's those kinds of developments were what allowed you to put radar in airplanes and fighter airplanes. And so this is just an example of that. And as a matter of fact, Western Electric was completely occupied producing tubes themselves, but anybody could make, I shouldn't say anybody, but they licensed and made sure that a lot of other manufacturers had all the information on the 6AK5. And as you know, for a long time after World War II, up into the mid 47, and so 6AK5 was the go-to high frequency pentode. Go ahead, next one. This is, you've seen this one before in another presentation. Vacuum tube production in the United States from 1944. This is original equipment manufacturing, and this is total. So this includes manufacturing, it includes exports, it includes all kinds of activities that were going on. The peak production year in the United States was 1955, in which we made almost 500 million tubes in that 1 year. And by this time, this was television, this was color television, and this was additional competition from the Japanese and their television receivers, which, by the way, of course, when the first ones were all vacuum tubes and they were imported. And of course, they didn't bring them here to have us put our tubes in them. They made the tubes too in Japan. And then the end of production of tubes in the United States. Go ahead, next. So it was a very painful reorientation after the war. On the other hand, there was all kinds of new stuff that radar allowed the development of the national traffic system we use to this day to control air traffic, missile defenses, additional commercial communications. FM radio broadcasting wasn't all that big a deal for a long time. But like I said, 55 was the highest domestic tube production year. New production facilities were built, and importation of tubes from overseas, Japan, Europe, began to erode U.S. dominance. And of course, they were engaged in dumping and all kinds of practices that the federal government to this day, we don't understand why they allowed all that to happen. But then again, I have already had my piece said about that. Go ahead, next choice, next slide. In 1945, RCA, this is 1945, I think it was November. Here's, you see the tubes start to be released, 6AT6, U6, BA6, BE6, 12AT, 35W4, 50B5. You guys all know those numbers. Go ahead, next one. Adoption of television. Initially, TV receivers use existing tube types. Everybody has seen 6SN7s beat to the dickens because they used them as vertical output tubes and they weren't up to it. And so they had to develop new tube types to handle the increased demands. And then you ended up with color television, transistors, and imports reduced and virtually eliminated demand for U.S. tubes. Go ahead. This is some Sylvania publicity, and this was typical of the construction in tubes in the entire industry. And here they're showing the difference between the old shoulder 5U4 and the new bottle, which also had the button base that allowed them to get the, I think the rating went from 250 to 275 mils for the tube. And also the tubes like the 6CD6, which was specifically intended and designed for horizontal output service and television receivers. And that whole process continued all the way to the end of the television era, and some of those 6JS6s and all those big tubes that were used in color television receivers, all the way up to the end of the production of color television sets. Go ahead, next slide. Okay, now we get to the audio craze. because this discussion is about tubes. On the other hand, if you don't have a piece of equipment that you want to operate and requires tubes, you don't have tubes, you don't have it working. And so the development of the demand is circular, of course, with vacuum tubes. The term high fidelity had been used as early as the zenith stratosphere in 35. Now, I know there was general use of the word fidelity before that, but at the same time, that's the first time I have ever seen any piece of printed literature that says high fidelity. And that was the switch that was on the radio that switched on the tweeter. Anyway, the 2A3 was termed by Vacuum Tube Valley and Kittleton as the mother of high fidelity. And that was the last big triode for audio that was released. It was the last industry offering to a large power triode, and the exception is the Western Electric 300A and B in triode output sweepstakes. Of course, Shade of RCA made a big case for it doesn't make any sense to build a triode audio tube bigger than a 2A3, and of course Western Electric said, I don't think so. So from that came the 300AB, the 845 and 211, we consider those transmitting tubes, and that's not there. The 6L6 was a major advance. Zenith started using them in 1937, and before very long, the whole industry was on top of that. Then the 6V6 came out, and then you had that whole series of All-American 5s, 50B5, all those tubes were also beam power tubes. RCA began pilot production of the 6L6 GC in October 1959. And that was the closest thing to the KT66 of 1937. The point is that tube was hardly known in the United States because they were so hard to, we didn't have an internet. We didn't have a lot of the communications and capabilities that we have to this day. That just gives you an idea of how far ahead of us they were. What many identify as a kickoff of a high fidelity autoplays was the Williamson amplifier, DTN Williamson. We're going to talk about that a little bit. The original Williamson circuit. This is what was developed before World War II. And the pure Williamson, now we get into a lot of personal opinions and preferences about broad soundstage, about a robust low end, The DTNW circuit originally had the two triodes, one directly connected to the other, driving two stages. And this is a power phase stage, the way it's configured. And then a pair of KT66s were connected as triodes. And about all you could get out of it was 15 watts or so. It was biased for Class A. The primary of that transformer, of the output transformer, 100 Henry minimum, 20 dB of feedback taken from the output secondary to the cathode of first stage. So if you really want to get picky, if your amplifier doesn't do all that, it's not a genuine Williamson. So there's many derived types which follow, often loosely called Williamson type amplifiers, but the Brits are there saying it's not really genuine. Go ahead, the next one. This is a recreation of the Williamson amplifier in the early format using 4-type 6J5 valves for the input stages made by Rogers Development in England. And you can see the KT66 is in there. And it really lit the fire under the audio movement in the United States. Go ahead, next one. This is me. I was looking for a picture of a record player to use, and I was searching the web, and I thought, I got one myself. This is my record player. It's an SL1200, and any of you who know this know that the SL 1200 went out of production about 10 years ago. And they're talking about bringing it back. And do you know what the proposed price is going to be? $4,000. I bought this thing for $400. Anyway, and it's gorgeous. And I have to say, the first real good record players or turntables that were put out when the LPs came out were nowhere near this good. But if you're going to have one picture, you might as well have a good one. This is a really good compromise between the ultimate nutcakes that spend $24,000 for a record player all the way down to the real cheapos. The thing that broke it in the United States is access to high quality audio sources, because 78 RPM records and AM radio weren't very good. And even FM broadcast on the old band was limited by the program material they had. And it was mostly 78 RPM records. So the LP disc in 1948 is really what knocked the door down on all this. Open reel tape, stereo LP disc in 57, a compact disc in 82. And now there's a recent resurgence in vinyl records. The sales of CDs are dropping off, and companies that never thought they'd ever have to make another LP record are running 24/7 to try to keep up. So this is what this started, the real crazy expansion of the high fidelity craze in the United States. Go ahead. I've had personal experience with both of these. This is a Mastering Quality 600 with a 620 speaker Ampex in 54, and that's a F4460 prosumer quarter track stereo open reel record playback unit in 1963. And those, you could buy pre-recorded tapes that were actually dubbed from the original masters. So high quality records, high quality program sources, FM radio, open reel tape, all of that is screaming for better speakers, better amplifiers, better equipment. Go ahead, next. Demand for higher power. The pure Williamson delivered only 15 watts of power. And as you know, when you're doing bookshelf speakers, you got to have a lot more power than that. So David Hafler and Herb Kiros formed Acrosound in 1949 to manufacture high-quality transformers. And they patented the ultralinear circuit in 1952. However, Ed Blumlein had patented that in England in 1937, but the patent was allowed in the United States because that patent wasn't valid over here. Hafler and Ed Laurent formed Dynaco in 1955, and anybody who knows anything about audio has had a lot to do with Dynaco. This development was combined with the original Williamson circuit, then modified to the single pentode triode tube. And the 7099 was a construction that Hafler went to RCA to get done, so that they could say that 1.5 volts input gave you full power output on a MAARC III, which was 60 watts. The long-term disdain in the part of many for transistorized audio equipment for high fidelity was actually part of the whole craze, because a lot of people didn't like the sound of transistor amplifiers, and I have a red-faced discussion. All of my own personal equipment is solid state. Next. So this accelerated the demand for amplifiers and tubes. Acrosound went in business and not only sold, they started out making transformers that were not ultralinear, and then they started selling them. And the Acrosound Ultralinear 2 amplifier was released in 57. And that was designed by Kiros, because by that time, Hafler and Laurent had gone off and started Dynaco on their own. Yeah, Dynaco. Go ahead. Next one. And of course, Macintosh has got to be reckoned with. The company was co-founded in 49 by Frank McIntosh and Gordon Gow. The unity coupled circuit, patented at the brand's inception, is still in use today with vacuum tubes, which helps. That's why I got it enclosed. Helps to impart a lifelike warmth and soul to the sound. And this is a photograph of the Macintosh MC75 limited edition released in 2000. I mean, these people are serious. New business created many companies' products. You know, you got all this suction. Everybody's building amplifiers. Everybody needs tubes. Everybody's trying to catch up. Hafler, the estimate was that they sold 125,000 Mark IIIs. And Mark, or the Stereo 70, there are some estimates that there were 500,000 of them made. And now you know why they're everywhere. They are all over the place to this day. Fisher Radio, 100,500 Cs just of that one model of stereo. Harman Kardon, Altec Lansing, I'll show you a little bit about that in a minute. Marantz, Macintosh, Bogan, Heath, they sold over 30,000 W5Ms. And they were all supplied originally with KT66s. Hey, okay, go ahead, next. So this interest in high fidelity created a new demand for specialized tubes. So you've got the 5881, which was equivalent to a WGTV 6L6, Tongsol 1950. They uprated the 6L6 from 19 watts to 23 watts. The 6550 Tongsol had a 42-watt plate dissipation. That was released in 54. The 6L6 GC, 30 watts plate dissipation, 59. These Westinghouse tubes, the 7591, 7861, 68, and 8417. 8417 and the Fisher 1000 will do 95 watts a channel. The tube had a GM of 23,000. You could drive it with a 12AX7. Foreign tube designations. Genelex. When I said earlier GEC, I was tangled up. Genelex was the name that they adopted for marketing their British tubes in the United States. So the KT66 was 25 watts in 1937. EL34 Phillips, 25 watts earlier. EL37 Blackbird Muller. KT88 Genelex MOV, 42 watts, 1956. And the 12AX7, of course, everybody's bonkers over 12AX7s, and whether you've got Dutch tubes made in Heerlen, whether you got Telefunkens made in Berlin or Ulm, or whether you got Mullards made in Blackburn, they're all here in the Bugle Boy. And of course, people don't realize how dominant Philips was because they owned Mullard. They owned Amphorex in the US. And they made it so hard to figure it out. You go through the United States Patent and Trade Office. That's one of the ways you can do research, because when they buy a company, they have to have rights to use their trademarks. And you got to file it with the US TPO. And when you do that, it leaves a trail that lets you know when it happened. So Philips had bought Amphorex in 1955. And it's almost impossible to find any other record of it other than the transaction that's a USPTO. Anyway, the KT88, Genelex 56, and all these. And of course, I'm very enthusiastic about the Russian KT120. Not to say anything about Russia and what's going on, and we'll talk about that in a little bit. Go ahead, next slide. So here's a KT66 with the Genelex label on it as marketed in the US, and you see it has that odd base that was what they used in that day. And there is a domestic British KT88 with a GEC label on the way it would have appeared if you had bought it in Britain. And these were the kings of the British power tubes, the KT88 being a real good original Gold Lion GEC KT88 is a bundle of shekels, I want to tell you. Go ahead, next. Of course, American Activity. Ironically, the first commercial use of this Tungsol 6550 was the Altec 340A. And Altec for a long time continued to use pentodes with peerless transformers. And of course, Hafler said, they're not as good as ours. And the Marantz 8B, which I think everyone recognizes as a massively gorgeous and fantastic piece of equipment. This is really something else. Go ahead, next. This is one of the last 6550As run in June of 17th, 1993. This was when the MPD factory that used to be the GE plant in Kentucky finally ran the last tube that I believe was manufactured in the United States, up to something I'll tell you about in a minute. On the other hand, it had the same specs as a KT88, but you put them in a Mark III and let them run for a couple of weeks and they start showing you nasty things going on inside the tube. They can't handle it. So these are around, and this actually has the MPD on it, and it says, it doesn't say it's a GE tube, it says manufactured to General Electric specifications. And I have this tube. Go ahead, next. But wait, there's more, you know. The 300B is reborn. Charles Whitener is CEO of the new Western Electric Company in Rossville, Georgia. The story of this guy's acquisition of the right and the ability to manufacture these tubes is an hour discussion in and of itself, and it's absolutely amazing. I was at a presentation that he made in Atlanta about 2 months ago, in which he demonstrated the equipment that they're making there and talked about all this, and it was very entertaining. They made tubes for a while in the old Western Electric factory. For a while, they made them in Huntsville, Alabama, under conditions of which I inquired, and he failed to respond to in any kind of detail. And then in Rossville, Georgia, they built this plant and they used the Western Electric name, the trademark, print, everything. This is a fantastic tube. And it should be at $1,500 for a pair of them. And so it needs to be good, and it has a 5-year guarantee on it. And I can tell you, I have measured a number of these tubes over different time periods, and it's not your grandfather's 300B anymore. It's juiced a bit. And I'm still trying to find out why. I have my suspicions, but I'm not done with this yet. Let me just leave it at that for the time being. He claims that the next tube that they're going to make is a 12AX7. He said we have all the drawings for Western Electric tubes, and we have all the cathode material we need from the Hawthorne plant in Illinois, which was where they made the cathode coating. He said we got enough of that stuff to last us for 100 years. And that's very informative. The 300B is used in a lot of high fidelity audio amplifiers, primarily single-ended, but there are a number of people, including myself, who are exploring other uses, but it ain't easy to drive one of these things, and that's part of the whole problem. Anyway, the point is that this is well, anyway, I asked him point blank, why don't you make a 350B? Because that's a 6L6 on steroids. And he said, well, the guitar guys want 6L6s. And I said, you're going to have to recreate all the drawings. If you look in the RCA archives, if you have all the drawings to make a 45, the triode, the 45 triode, it's like 25 pages of detailed specifications for the wire, how it's bent, what the dimensions are, what gets welded, where. A 6L6 is a complicated tube to make. And he's got the drawings for the 350B, but he wants to make a 6L6 when he'd have to generate all new drawings for it. I don't know where he gets them. We need to explore this some more. Anyway, this is an ongoing situation, but they are in production on these tubes, and you can buy them for $700 a piece or whatever, $1,500 for a pair. Go ahead, next slide. More yet, the guitar guys. Electronic amplification for guitar players has been an issue since the early 1930s. We got guitar people here too. Tremendous demand for electronics to satisfy the guitar craze. Many performers prefer vacuum tube sound and distortion from overdriving amplifiers. Recent lookup, I did a lookup on Google. How many active manufacturers of guitar amplifiers are active in the world? 92. There's a lot of this going on. I mean, it's fantastic. And so the point is that all of this activity in the hi-fi, the vacuum tube people, the demand for this stuff is creating a reason to continue producing vacuum tubes. Go ahead, next slide. Fender amps and speakers. A lot of you guys will recognize this stuff. Keep going. Next slide. 4 electro-harmonics KT88 power tubes inside a Traynor YBA 200 bass guitar amplifier. Now that's some real heat and some real power going there. There's a Mesa Boogie Mark IV, a guitar combo amplifier. I mean, this is big business and there's lots going on. Go ahead, next one. High quality audio and guitar amplifiers. Both classes of amps require many of the same tube types. With some exceptions, the new old stock tubes are considered most desirable by the audio enthusiasts. They're available from many sources. Recent military activity in Europe has made access to tubes made in Russia difficult. About half, my information is that about half of all the current production tubes made came out of Russia. And that has been generally stopped as a result of the war in Ukraine. And so that has made a worldwide shortage in vacuum tubes of these types. Go ahead, next slide. New sensor. This is a guy in Long Island who controls Electro-Harmonics, Mullard, Tungsol, Genelex, Gold Lion, Soltech, and Svetlana. He controls all those brands, and they're all made in this factory in, can't remember the name of the town all of a sudden, in Russia. Anyway, Saratov. Okay. Shuguang, by the way, the guys that are in the middle of this, the Shuguang tubes are referred to as Shugis. Anyway, they just returned after a 5+ year hiatus due to a fire, questionable and variable quality. The distributors I know won't even buy the tubes because they're so screwed up. They used to be good. So if you got Shuguang tubes made before the fire, you're probably in pretty good shape. Pisvane, that's a spinoff of Shuguang that happened before the fire. Pisvane and Linalai are the premier Chinese tube brands now active, and their quality is excellent. This is what I'm hearing from the distributors. JJ, this is interesting. JJ is an independent manufacturer in the Slovak Republic. Tesla was a company that made vacuum tubes. They didn't make all that many of them, but they were a very high quality producer. They shut down when everybody else did, and a bunch of people bought their equipment and put the whole thing back into production. And that's where the JJ tubes come from. And they are independent as opposed to all these brands that are tangled up with each other. And they're the successor to Tesla, and their reputation is very good, very good. So many eyes are on New Eco for new additions to their product line because what an opportunity for them. The question is, can they reach it? Can they get there? This all depends on the latest information that you can get. And my recent feedback is that JJ is doing extremely well. This is under the Tongsol name. It was distributed by New Sensor using the Tongsol name. It came out in 2017. It was a new tube design from Russia and a tube plant in Saratov, Russia. I have two of them here, and these are tubes. You know, in Crocodile Dundee, when he said, "That's a knife," this is a knife. And I say, "That's a vacuum tube." And I've got a couple of them here. I'd be happy to show anybody that's interested in actually looking at one. Is they work as well as they look. You can plug in with to replace a KT88 if you do some minor rebiasing. You got to make sure you got enough filament power to drive it, though. And this is a plug for Viva tubes in East Hampton, Massachusetts. There's also a KT150. And this tube has a 60-watt plate dissipation. This thing is a moose. They tell you can't have any more than 51,000 ohms in the grid. And they draw some grid current. They draw a couple of microamperes of grid current, and that's stable and normal. And see, with the Jagundo, I can see all that. Okay, so, and the Russians, you know, they say the tube will go up to 800 volts or whatever, but they give you charts that only, you get one set of plate curves, that's all. And in essence, they're saying, here's the tube, you figured out. And with 60 watts of plate dissipation, you got lots of room to do some figuring. Anyway, that is a tube. Go ahead, next one. And I'm just here to tell you, I appreciate your attention. This is me. If anybody wants to pursue any of this further, those are my phone numbers. This is my Gmail. Thank you very much. Has anybody got any questions?
Paul,
Yes.
is the 2A3 and the 45 used much in audio these days?
The 2A3 is, but I don't know of any really good circuits, and I'm working on that. I really am. And the 45 is primarily a tube that's used for old radio restoration. 2A3s were used in a bunch of equipment, the super high-end stuff, Scott, and in the Stratosphere and some of those other designs in the late 30s and so on. Everybody has got experience of their own, and I'm sure a lot of their experience differs from mine. I did as much research as I could to try to make this a balanced presentation, but somebody's always going to be unhappy. Yes.
You mentioned that the Radio Manufacturers Association developed a standard coding or standard nomenclature for tubes. If you see a nomenclature, can you tell what it means, like this?
Like a 6L6 and 6B6. Is that L standing for something specific, or is it just for the B?
No, it's generally when RCA came with some developmental number, which would have been a G471Y or whatever, they would say, okay, the next letter we're going to issue is L, so it's 6L6. And there's a lot of confusion in that. As an example, a 6BZ7 is a twin triode high frequency tube. It's not an audio tube. A 12BZ7 is two halves of a 12AX7. Four halves is what it amounts to. It's two triodes and each one is a full 12AX7. It doesn't make any sense. And a 12L6 is not a 12 volt 6L6. It's a 12 volt 50L6. So there's all kinds of screwy stuff going on within that whole structure as well. Anybody else? Yeah. Uh-oh, here it comes.
Oh, is this microphone? Well, let's see if I'm Sinatra. That's an EL 37 at all.
I don't get it.
The EL 37?
The EL 37.
Yeah, you didn't mention that at all, but I guess that's more of a British tube.
It was a predecessor to the EL 34.
Okay,
And Fisher used it in some of their early
yes.
receivers.
But they also used it in, I believe, an amplifier.
It's got
The
this,
80A.
it's got exactly the same specs as an EL 34. And I'm still not clear as to what the difference was, but it had a kind of hunchback shouldered shape.
Right.
And the EL 34 is a straight bottle.
Now, my understanding is the last number in the American system, like when you see a 7, is a number of elements in the tube. Is that correct? That's my understanding.
I'm not hearing what you're asking.
The last number, like when you see 6BQ5 or
Yeah.
you see
It's
the 12AX7 is the 7 stands for the number of elements in the tube.
of active elements in the tube. Yeah,
Right. Okay.
that's what it's supposed to. It doesn't always, because a 6BS8 and a 6BQ7 are virtually the same tube, and yet they got different element numbers on the end. Because they just ran out on the other number, on the other letter, so they said, what?
Actually, Sid Lee talks all about that in his book Tube Lore. So you can get up.
Randy's got another one if we've got time. One more.
Just a remark, actually, you did have a EL 37 on one of your slides there, so he might have missed that. And that was used primarily, I think, for one of the hi-fi amplifiers, the Lafayette KT something or other, have a pair of 37.
Well, let me just say this, the EL 37, the suppressor is tied to the cathode inside the tube.
Exactly.
In the EL 34, the suppressor is brought out separately to pin 1. And that lets you connect it as an absolutely pure triode. He talked about that in the presentation last year in the triplet tester, because with the tester, you can actually test it as a pure triode. You can't do that with a EL 37.
Yeah, unfortunately, the 37 is an easier to drive tube than the 34, but 37s are rare as hen's teeth.
Yeah, they are. They're
I
very,
have a couple of hen's teeth.
you got them. That's where they all are. I know a guy who's got a whole box of them in the original boxes. I'm still trying to work that. All right, anybody who wants to take a close look at this jewel is welcome to examine it. It works. It works as well as it looks. It's a direct plug-in for a KT88.
That's a tube. It weighs a lot too.